Hello everyone, in this lecture I want to show you the applications of trigonometric equations. We have a word problem here. It says the depth of the ocean at a swim buoy can be modeled by the function d of t, and d stands for depth of the water. D of t, that is a function of time, equals 4 plus 2 times sine of pi t over 6. So this is a trigonometric function. Specifically, it's a sinusoidal function that is used to model the depth of the ocean at a swim buoy. And d is the depth of the water in meters, and t is the time in hours. If t, the time, is between 0 and 24, that is one whole day, 24 hours basically, then it says consider a day when t equals 0 represents the midnight. So basically t equals 0 is the midnight, so t equals 1 would be actually 1 a.m., and t equals 2 would represent 2 a.m., and t equals, let's say, 11 would represent 11 o'clock in the morning, just before noon. And it says determine when the depth of the water is 3 meters. So within this 24 hours, within this one whole day, we just want to find out at what times during the day. Is it like 7 o'clock in the morning? Is it 7 p.m. at night? Is it 11 p.m. at night? Or is it at noon? We want to find out when the depth of the water is exactly 3 meters. That's what we want to find out. So to do the question, we're going to say that d, the depth of the water, is supposed to be 3 meters, right? So we have the equation. So we can substitute 3 for d, and what you see in front of you is nothing but a trigonometric equation. So you need to solve this trigonometric equation for time t. If you can solve this trig equation, then you find the time at which the depth is 3 meters. And this could not be like only one time, because the nature of the fluctuation of the water or the depth of the ocean basically is like periodic. So we're going to see. So I'm going to go 3 minus 4 equals 2 times sine of pi t over 6. And 3 minus 4 is negative 1. Dividing both sides by 2 gives me sine of pi t over 6 equals negative 1/2. So this is a trigonometric equation. So we know that the angle, whatever it may be, it could be simply sine of theta or sine of x, or in this case, sine of pi t over 6, whatever it is, that's equal to inverse sine of negative 1/2. Okay, and inverse sine of negative 1/2 is, if you use a calculator, you will get the answer as negative pi over 6. Okay, negative pi over 6 radian. But the thing is that if I write negative pi over 6, then time will end up being a negative number. And time cannot be negative, obviously. So it doesn't make sense if I say the answer is negative pi over 6. I have to pick an angle whose sine is negative 1/2, of course, but at the same time, the angle is positive. So instead of negative pi over 6, I'm going to use the first coterminal angle with negative pi over 6, which is negative pi over 6 plus 2 pi. And that would be, of course, 11 pi over 6. So 11 pi over 6. So the reason why I didn't write negative pi over 6, as I saw on the screen on my calculator, after punching in the sine of negative 1/2, is because time cannot be negative. So I was obliged to use the first coterminal angle with negative pi over 6, that is 11 pi over 6. How did I get 11 pi over 6? I added negative pi over 6 with 2 pi in order to find the coterminal angle with negative pi over 6. So this is an okay answer because it's positive. Okay, so this is one solution. The other solution is pi minus inverse sine of negative 1/2, as we have discussed before. We're not learning about solving trig equations right now. This is just the final step. It is the application we're discussing now. So this would be pi minus negative pi over 6, which would give you a positive answer, and that would be 7 pi over 6. So 11 pi over 6 is one answer. The other one is 7 pi over 6. Both are positive, both are admissible. But let's not forget that this was not just simply theta. This was not time t. This was pi t over 6. So basically, pi t over 6, which was our angle, equals 7 pi over 6 once, and once again, it is equal to 11 pi over 6. I can call this t sub 1, t sub 2. First solution, second solution. Canceling out pi from both sides, I end up with t1 equals 7, and here I get t sub 2 equals 11. Final answer. Now, what's the unit of measurement? Well, it says 7 hours, 11 hours. So these are the roots of that equation, basically. What does that mean? It means after 7 hours or after 11 hours, the height of the water is 3 meters. So I'm going to write this down. I'm going to say maybe here, after 7 hours and 11 hours, the height, or I should say ocean depth, is 3 meters. It says the depth of the ocean at a swim buoy can be modeled by that function. So that's what it is. Now, we want to know what time of the day that would be. That's what we want to find out. And this is not difficult because we can say the period of this sinusoidal function is always 2 pi over k according to the formulas we have studied in the past. But k is here pi over 6. So that gives you 12 hours. The period is 12 hours. So if it is 12 hours, then not only after 7 hours and after 11 hours, we're going to have a depth of 3 meters, but also in the PM, in the afternoon, in the evening, this will happen again because the period is the length of one cycle, and that cycle keeps repeating. So we have a cycle in the morning, we have a cycle in the afternoon, perhaps. So I'm going to say 7 plus 12 is 19 hours, and then 7 plus, not 11 plus, sorry, 11 because I already added 7, didn't I? So 7 plus 12, and then 11 plus 12, which is 23 hours. Okay, so at these times, 19 hours and 23 hours, again, the height is going to be 3 meters. That's in the next cycle. And the question says time is between 0 and 24. So within the first 24 hours. I'm not saying the next day and next day and next week what's going to happen. Of course, we can keep adding the period, we can keep adding the 12, and we're going to find all those times or hours that the depth was 3 meters. We can do that. But the question says limit yourself to only one day, that is 24 hours. Okay, so 7 hour, it would be 7 a.m. in the morning. 11 means 11 a.m. in the morning because remember what I said, t equals 0 here, t equals 0 represents the midnight. And then 19 hours, that would be what time in the afternoon? It would be, I believe, it would be 7 p.m., right? So that's 7 p.m. and this would be 11 p.m. actually. So 11 p.m., 7 p.m., 7 a.m., and 11 a.m. These are the 4 times that the depth of the water will be 3 meters. So I'm going to say at 7 a.m., 7 p.m., 11 a.m., and 11 p.m., the depth of the ocean is 3 meters. So that's the final closing statement I write. And then just to show you a visual of what is happening, if you look at the equation 4, is that vertical shift or displacement of the sinusoidal function, which represents the axis of the curve. So 4 is right here, and the amplitude is 2, clearly. So 2 units above this, that's the maximum line. 2 units below that is the minimum line. So this is the minimum line, which is actually d equals 2 meters. This is d equals 6 meters, which is the maximum line. And this one is going to be d equals 4, which is axis of the curve, basically, right? And the graph of depth of the ocean is fluctuating in between these values, 2 and 6. Maximum value is 6, minimum value is 2, and the period is 12, as we said. So 12 hours is somewhere here, and that's here at t equals 0. If you plug in 0, t equals 0 at midnight, basically, sine of 0 is 0. So 0 plus 4 is 4. So that means that at midnight, the depth of the ocean was 4 meters, okay? And then after that, it starts going up, increases to 6 meters, and then comes back down, and then again goes down, and then goes up, back again at 12 hours. It is again 4 meters. This is the first cycle. The next cycle, again, can be drawn similarly, like this. This is a sketch, of course. And where is 7 a.m.? 7 a.m. is somewhere here. So this is 7 a.m. And we see exactly the height is 3 meters at 7 a.m. And then at 11 a.m., which is right here, one more time, we see that exactly the depth is 3 meters. And this happens again in the next cycle. We said at 7 p.m., which is 19 actually. So at 19, again here, and 23, I believe, was the next one. So 23, go up, and this is exactly showing a height of 3 meters for all those 4 points. So this is 7 a.m., this is 11 a.m., 7 p.m., and this is 11 p.m., which is represented by 23 hours. T equals 23 hours. Okay, so basically, let me just add that this was T sub 3 and this was T sub 4. So 19 hours and 23 hours, T sub 3, T sub 4, T sub 1, T sub 2, 7 and 11 hours that we derived it initially from solving the trigonometric equation. And what was the trig equation? We simplified, we obtained, it was this. This was a trigonometric equation, we solved it, and this was an example of applications of trigonometric equations. You learned how to solve different trigonometric equations. Why? Because you can use that knowledge of yours in solving word problems like this. I don't think there's anything else I add except that I'm going to label the graph. So d equals 4 plus 2 times sine of pi over t over 6. Everything else is perfectly labeled. So these are the 4 times when the depth of the water is actually 3 meters. I hope you understood how this problem was solved. You can always, watch this like several times and try it by yourselves. Spend the hours and practice, and I'm sure you'll be successful. Thank you very much for your attention.